Alright, let's take a look at our lesson on transformations. There are 5 standard basic transformations. Let's go through each of them. So one would be a vertical movement, vertical shifting, where you would either shift up or down. That basically means that you would add or subtract a number from the function, provided the number is positive. Then we have horizontal shifting. So instead of the vertical shifting, we have horizontal, and that means that we could shift to the right or to the left. Now, the horizontal shifting is a little strange because instead of, like with the vertical shifting, if you add the number, you go up. If you subtract the number, you shift down. For the horizontal shifting, it's really opposite, which is very, very strange. The number is inside with the x, and if it says x minus c, then you're going to go right. And if it says x plus c, you're going to go left, which I know is very strange. We'll look at some examples of all of these. The second, so where we are shifting up or down or left or right, that's one kind, main kind. Another main kind is the stretching and shrinking. And so horizontal stretching and shrinking is also quite strange because the number is inside with the x, and again I'll show you what that means in an example. You know, if c is greater than 1, then what happens, like in this example right here, the it shrinks it by a factor of 1 over c. Of course, always opposite. The transformations that involve x are always opposite of what they should seem, or what they seem, because it looks like c, let's say for example 2, it looks like 2 is multiplying to the x, when in fact the result of what happens is it's like dividing by 2 or dividing by the c. So that creates a more compact graph. But if the number c is between 0 and 1, then it's going to stretch it out like it did in this example. It's going to make the graph wider and not more compact. For vertical stretching and shrinking, a little bit more, the transformations that involve y are a little bit more straightforward. You know, whatever number it is outside multiplying the function. If that number is greater than 1, then, you know, it's going to make that stretch. It's going to stretch vertically, so it will get bigger, you know, taller. And if the number c is between 0 and 1, then it's going to shrink it, like in this example. And then that takes us to the last major classification, I guess, if you will, is reflecting. We would reflect a graph. So if we're multiplying by -1, multiplying the whole function by -1, what's going to happen is it's going to reflect the function over the x-axis. So all of the y values that were positive, since you're multiplying the y values by -1, turn negative. And so that causes it to reflect over the x-axis. But on the other case, if the negative is affecting, you know, inside the function, affecting the x, then what happens is all of the positive x's become negative x's and vice versa. And then we have a situation where we are reflecting over the y-axis. Now, these transformations hold true for any function. It's actually pretty cool. It doesn't matter whether you're working with a, you know, polynomial or a radical or a trigonometric function. They all hold the same. So let's look at some examples. Or basically, we're going to look at one example and we're going to transform it many different ways. So there are two main strategies for completing problems like this. And really, whichever strategy you want to choose is totally your choice. One strategy is to identify what the transformations are, and then you just look at the graph that you're transforming and you graph it. That's one strategy, where you basically show absolutely no work. You're just doing the transformations kind of in your head. A second way would be to write parent points down, or the main important points from the graph, and then you transform the points. I have found, over the years that is a safer way. Usually students that transform points are less likely to make mistakes, but it takes a little bit longer. So whichever technique you decide to do, that's totally your choice. What I'm going to do is I'm going to demonstrate the second technique that I talked about, where you would choose a parent point, the parent points, and then you would transform the points according to what transformations you're asked to do. So looking at our parent, which is the f of x, we're going to choose the significant points, which would be where the graph changes. Okay, so these are the, and actually it is pretty important, the zeros of the function, where y is 0. So these are going to be our parent points. And you can have as many parent points as you want. The danger would be is not having enough. So let's write down our parent points. This one farthest to the left, that would be a -3, 0. Then we have -2, 1. Let's see, we have 0, 0. We have 1, -2. Then we have 2, 0, and let's see, 3, 2. So these would be the points that we would come back to in each case when we're asked to transform. We would come back to these points and change them. Our first example, we have this transformation. See, that's inside with the x. So what that means is this is left 1, which means we're going to subtract 1 from all x values. Okay. This transformation right here means down 2, so we're going to subtract 2 from all y values. Okay, so here's these are our values for number 1. So we're going to take all the x's and we're going to subtract 1. So a -3 minus 1 is -4. -2 minus 1 is -3. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. And 3 minus 1 is 2. Those are our new x values. Okay, so now let's take our y the y values, and we're going to subtract 2 from all the y values. So 0 minus 2 is a -2. 1 minus 2 is -1. 0 minus 2 is -2. -2 minus 2 is -4. 0 minus 2 and 2 minus 2. Okay. So once we have the transform points, really all we have to do is graph these points and then connect them together, and we have our new graph. So we go over 4 and down 2, over 3 and down 1. I would suggest that you connect as you go so it doesn't get confusing, so you're not confused on what connects to what. Let's see, -1, -2. Then we have 0, -4. We have 1, -2. And then we have 2, 0. And that's our transformed graph. Okay, so if we visually look at this graph, we can see by comparing it to our original graph that indeed it has been shifted left 1 and down 2. Okay, so let's look at our second example. This transformation is a reflect over the x-axis. Okay, and we want to, so these are points number 2. So when we reflect over the x-axis, what we're doing is we are multiplying each y value by -1. That's what we're doing. So the original x values remain unchanged. Let's look at again now. This is a danger. We don't go back to these points right here. We go all the way back to the parent points. So let me shrink this just a little bit so we can see. So the x's aren't changed. So we just copy them down. -3, -2, 0, 1, 2, 3. The y values are all multiplied by -1. So 0 times -1 is 0. -1, 0. So see, I'm multiplying everything by -1. Now I have my new points, and I'm just going to plot them. So -3, 0, -2, -1, and I'm going to connect as I go. 0, 0, 1, 2, 2, 0, and 3, -2. All right. So let's compare this to our original. And so what has happened is the entire graph has been reflected over the x-axis. You can see that to the left of the y-axis, where the graph was above the x-axis, now it's below. And to the right, you can see a mixture. You know, we've got some below and some above, and it's switched. So we can see that it worked just fine. Okay, let's move. Now, number 3 is like the hardest one ever. So let's skip that one for just a moment. That when you do the opposite value inside of the x, that's like the hardest one. So we're going to do that one last. Let's do number 4 and 5, and then we'll come back to number 3 because that one's is a little bit crazy. So let's look at number 4, what's happening here. So this transformation is everything is absolute valued. And so that means that all y values all y values, gosh, I can't even write values. All y values are positive. All right, so let's do, so this is number 4. So the x's haven't been changed, they're all the same. The y's are all positive or 0. Okay, so let's graph that. So we have -3, 0, -2, 1, 0, 0, 1, 2, 2, 0, and 3, 2. Okay, and we compare this to the original, and we see basically what's happened is this piece that was underneath the x-axis has flipped up and is now over the x-axis. See where this one is right here? That's basically, that's flipped up, and this piece right here, I'm so silly. This is 3, 2. This piece right here is the same. I mean, that's the same as it was. The only thing that changed was the negative y piece turned into a positive y piece. Then number 5, this what we have going on here, this is outside of the x, so it affects the y. This is a vertical shrink. And so what we would do is we would multiply all y values by 1/2. Okay, so this is number 5's. The x values stay the same, so we just copy them down. -3, -2, 0, 1, 2, and 3. Now all the y values are multiplied by 1/2. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. 0. -2 times 1/2 is -1. 0 and 2 times 1/2 is 1. Okay, so let's graph this one. So -3, 0. -2, 1/2. 0, 0. 1, -1. 2, 0. And 3, 1. Okay, comparing it to the original, we can see that it has indeed shrunk vertically. It's got a vertical shrink by 1/2. It's squished, shrunk. The top is lower and the bottom is tall. They all move into the x-axis. They're shrunk. All right, so let's tackle number 3. Okay, so let's think about what it is that's happening. What is happening is all of the x values have been turned positive. So let's write this down. All x values are turned positive and take on the y values of their positive counterpart. You're like, what? Have you lost your mind? I know, it's crazy. So let's just, now it's not that, so when I plug in, if I plug in a -1, I did plug in a -1, so the x value that I plugged in is a -1, but it turns into a +1, and then the y value that we would choose would go with the positive y value, if you will. So we would choose the y value for +1, not -1. All right, so the only ones that we need to be concerned with are the x values that are negative. The x values that are positive aren't going to change. In fact, and 0. 0 is not going to change. So we've got 0, 0. We've got 1, -2, 2, 0, and 3, 2. Those aren't going to change. So why don't we graph that? And the rule of thumb here is what people say is with one of these, the right side of the graph is unchanged and the left side of the graph is a reflection of the right side of the graph. And you're like, what? Okay, so let's work through the logic behind that. So on our first example, our first point, it was a -3, right? But the -3 is going to be turned into a 3. That's what's going to happen because of the absolute value. So we have to look up here at this chart and see what was the +3 mapped to. Well, the +3 was mapped to a 2. So the point that I'm going to graph is -3, 2. That's the point that I'm going to graph because I put in a -3, it turned to a 3, and it took the 3's output. So I would graph a 1, 2, -3 and 2. -3 and 2. Gosh, I don't even know. It's 2. -3 and 2. There we go. Okay. So let's explore the next point, the -2. So the -2 would take on a 2. We look up here, we see that 2 value is at 0. So the point that I'm going to graph is -2, 0. So -2, 0 would be right here. And then I have 0, 0, and I'm thinking, okay, I don't have enough information. What do I need? I need 1, right? I need to know what happens at a -1. I didn't need that on any of the other ones, but what happens at a -1? It takes on the value of 1, and 1's value up here is -2. So what I'm going to graph is -1, -2. So -1, -2. And we can see that it truly is a reflection of the right side. So if this is really confusing to you, I get it, because it is very confusing. It's the hardest one. And if all the points that I did just really mess you up, you could actually remember that for this type, the right side of the graph, so this side right here, is unchanged, and then you just reflect that side to the left side of the graph. All right, so we finished on a crazy one, I know, but that gives us a pretty good basis for our transformations.